Right, and welcome to web security, one of the other main topics in the computer and network security course. The web has evolved tremendously over time. So in the past, everything was really simple. We had a browser and we contacted a server, and the server would send back a reply, both on the HTTP protocol. And this is still the picture that many of us have in our heads when we think about the web. But over time, the web became more complicated. For instance, we had a browser that actually went through a firewall and perhaps used a cached copy of the web content in a proxy server, and the proxy server would actually be communicating with the actual web server. So now it becomes more complicated. There's more moving pieces in this picture, but it's still something that we can wrap our heads around. Nowadays, however, the situation has changed even more dramatically. We have our browser that talks to our firewall, and through the firewall we actually get maybe a cached copy from the and the proxy server gets it from the real server. But on top of both the client side and the server side, there's a whole bunch of additional things. There's scripting, there's additional services. Maybe you talk to an application server via some um, uh, script that runs on the server. We do really complicated things at the client side. It's a mess. And all of this somehow has to be kept secure. Okay? Some of these things have become super popular, and then have disappeared again. ActiveX and Flash, for instance, no longer exist, but JavaScript has become extremely popular. Okay? On the client side. On the server side, we find a plethora of other tools including PHP, and we'll look at some of these in the remainder of this lecture. In fact, what we're going to try and do to a large extent is abstract away from the specific solutions. We're going to talk about client-side scripting, server-side scripting, and then give examples from a whole bunch of these languages. We don't really care whether it's CGI, PHP, or on the server side, and whether it's JavaScript or something else on the client side. Each of them may have their own vulnerabilities, so we need to in that sense. But for the mental picture, conceptually, it doesn't actually matter all that much. Okay. So, right. So what we're going to do is we're going to do a vulnerability analysis for web applications. We're going to look at vulnerabilities in protocols, for instance, regarding the authentication. Certainly, old-style authentication in the web was quite vulnerable. We're going to look at vulnerabilities in the infrastructure, and we're going to, for instance, have an example there of response splitting. We'll get to that later. Don't worry about that now. We're going to look at the vulnerabilities on the server-side portion of the application, and examples of those are, well-known vulnerabilities such as SQL injection and cross-site scripting. But we'll also look at the way sessions and sessions are implemented and cookies are handled. And then we're going to look at vulnerabilities in the client side of the application. So the browsers themselves are vulnerable, but also some of the scripting tools that we run on top of those, and how they interact with their environment, maybe the document object model and some other things. Okay, so that's on the agenda for this set of lectures on web security. Okay. And to start off our lectures, I would like to begin with just a brief introduction of how the web functions roughly. And it really is more or less the early picture, the simple picture that I'm going to talk about, where we send a request to a server, and the request consists of a header and then an optional body that is separated that are separated by a carriage return line feed. And the header contains a number of things. It contains what kind of method you want to use. Do you want to do a get? Do you want to do a post? Or do you want to do a head where you only obtain the headers? but not necessarily the content of the data. It contains resources. For instance, you're interested in obtaining some doc.html file. It contains which protocol we're using. Are we using, HTTP 1.1, for instance, or maybe an old HTTP 1.0, and a bunch of other things, right? So-called headers, general headers, request headers, and entity headers. And the body is considered as a byte stream. So if you post something, it's basically treated as a byte stream. So like I said, we have a number of methods. The most common ones are get, head, and post. So where get requests a transfer of, maybe a document or a movie or what have you. Head requests a transfer only of the metadata, the header meta information. And post allows you to send data to a server. Okay, so for instance, a message or a picture or a movie or whatever. These are not the only methods, though. There are many other methods that are much less common, such as options, put, delete, trace, connect. We're going to mostly ignore these methods in this lecture. We don't really need them. Have a look at the slides if you want to know what they're about. We're going to focus on the most common methods. Okay. What about the resources? So the resources are specified by means of an URI or an absolute path. Okay, so you have an identifier for a resource, which is a URI or an absolute path. And what you can do is you can specify what file or document you're interested in using an absolute URI, such as you want to get this from this server, and then you want to have that document. Okay, you can also specify this without indicating the server itself, right? So the absolute path only on that particular server, where you say, get /index.html. For instance, both of these are used in the older version of HTTP. You can't. I'll skip the difference between the two versions of HTTP for now, and only get back to that when it becomes pertinent. We will mostly talk about protocol versions beyond 1.0. Okay, so let's give an example. If we want to send a request, what we actually send on the wire in a TCP connection is something like this. We want to get something, right? So this resource we're interested in getting, and we want to use the HTTP 1.1 protocol, and we want to send that to a host called Kuji, and it runs on port 8080. Okay, then it has some headers about date, something about cache control, that no caching, which used to be called a pragma, no cache in the older version of HTTP, and it's coming from me, and it maybe has a refer field, and we're only interested in getting that content if it was modified since a particular date. Now, in HTTP 1.0, it is not possible from just looking at the request line which server is supposed to process the request. So you do something like get /index.html HTTP 1.0. And therefore, it becomes impossible to have multiple servers running on the same, multiple web servers running on the same IP address. So that was fixed in HTTP 1.1, where we now have a host field that is required. It's a mandatory host field that you have to specify. So you can still do get /index.html, but you have to have in HTTP 1.1, you have to have this host field, specifying that in this particular case is for foo.com. Okay, what about HTTP 2? Well, HTTP 2 looks very much like HTTP 1.1. It's derived from Google Speedy work, and it has a number of performance improvements over HTTP 1.1. For instance, in HTTP 2, a server can push content. Okay, so you can send data for queries other than what the client explicitly asks for. Okay, so if the server knows that a web browser will request that data at a later stage, right? Because the web browser requires it to render a page, you can wait for the browser to ask for this data, or you can send it proactively to the browser, and that's what HTTP 2 allows you to do, and that means you save round trip times. Okay, so those were the requests. What about the replies? Well, replies are somewhat similar. They are also composed of a header and a body that are separated by a carriage return line feed. And the header contains, the protocol version again, so maybe HTTP 1.1, a status code, right? So whether or not everything is okay, the page was not found, or some other error code, some diagnostic text, and some other information, other headers again. Again, general headers, response headers, and entity headers. And just like in the request case, the body is a byte stream. So if you're sending a reply back to a client with actual data, that body is treated as a byte stream. So here's an example of a reply. It's sent with the HTTP 1.1 protocol and a status code of 200. Okay, so this is actually content that was found that was actually delivered to the client. Okay, date, the server that was used, the type of the content, so it's text, HTML, and it was last modified in 2008. And here's the actual, so the carriage return line feed, and here's the actual content. And this is all old stuff, and it's been pretty much unmodified. There's actually a bug in this example, and if you look at this carefully, I'm sure you'll find it. It's not a very interesting bug, but I made a mistake when typing in this content. Have a look. See if you can find it. All right, and then let's talk about the header field. So there's a link there that tells you more about header fields, and like I said, there are for the both the requests and the responses are different types of header fields. There's general header fields that talk about the message, right, and not so much the resource in it. For instance, what you want to do in terms of caching, right? Is caching allowed? Is it what is the date for this message? What is the encoding that we use, right? All these kind of things. Then there are specific request header fields and response header fields. For instance, for request header fields, we can determine what is acceptable as a response, what is the host that we're sending it to, what authorization credentials do we have, where is this coming from, do we only want to receive if it's modified since a particular date and time, what is the user agent that we're using, refer fields, and so on. And I just want to point out again that the pragma general header field is something that was used only in HTTP 1.0 for cache control. HTTP 1.1 used cache control directly. Okay, so the accept header field indicates what is acceptable as a response, and that is specified as a MIME type. Okay, something that indicates what content the client can understand. Those are the request header fields. In the response header fields, we find similar things. So the location, what server generated the reply, the www-authenticate for authentication, and so on. And finally, we have entity header fields that specify the methods that can be evoked on a particular resource, the content encoding, which could be, I don't know, gzip or what have you, content length, the content type, which is a MIME type indication, when it expires, when it was last modified, and so on. So again, some more specific information here. The allow header field will tell you which methods can be evoked on the resource, and it must be sent if the server responds with a 405 error message. So the method is not allowed, you have to say what methods are allowed. The content encoding, like I said, it could be gzip, it could also be compressed, it could be a bunch of other things. And the MIME types could be HTML, text HTML. It could be some multi-part with some boundary that is indicated, and so on. The URI is specified according to a specific format. Okay, and the syntax is that it starts with a scheme, for instance, FTP, HTTP, mail to, or telnet scheme, an authority, which indicates the server essentially that you're sending this to, a path, and then potentially query parameters. Okay, so the URI that represents references to a resource can be either absolute, where you actually specify the full server name and then the path to the resource. It can be an absolute path without the server name, where you just specify this path to this resource on whatever server this is currently relevant to, or it can be a relative path, which is basically relative to the current the existing path, current working directory, if you want. Okay, so that's I think none of this will be surprising to you. How does it work with authentication? Well, the web provides a number of ways of authenticating a user, and we're going to look at authentication in more detail at later stages also. But first off, let's start with the most simple authentication schemes that the web has to offer, which is a really simple challenge response scheme. And the idea is as follows: you contact a web server, and the web server, if authentication is required, says, sorry, I cannot provide you with whatever you're looking for until you authenticate yourself. Okay, so it's a 401 with this www-authenticate header that I alluded to earlier. Okay, and that is known as a challenge. And then the client needs to provide the authenticate header, which is the response. So it's a challenge response scheme. And only if the client provides the right response, the authentication is successful. Okay, so the credentials have to be provided in the response from the client. Now, the basic authentication is really simple. You provide a www-authenticate header in the response field, which says this is using basic authentication, right? This really simple authentication scheme for these reserved documents, right? So the realm that we're looking for in terms of authentication is reserved documents. Okay. If you receive it as a client, you now try to access this again, but now with the appropriate credentials. So the client retries the access and now includes in the header a field, an authorization field, that contains a cookie composed of base64 encoded username and password. Okay, so here we say that in the client request, it's basic authorization that we're basic authentication that we're providing, and here is the username password. Now this looks like it cannot be read and it doesn't reveal any information because it looks very much encrypted or so, but in reality, of course, it isn't, right? This is just base64. So if you look at this, it actually contains the username and password in the clear. So it's not very good basic authentication. So slightly more advanced authentication was offered in HTTP 1.1, where you have an additional authentication scheme, and that is more secure and it's based on cryptographic digests. So what the attacker does, what the server does when a client contacts it, it still tells the client, look, you have to authenticate first, but here's a nonce that I want you to use. And then the client creates a new message that consists of additional fields. One of the fields is a digest of the username, the password, the given nonce value, the HTTP method, so get or put or get or post or add or so, and the requested URL. So you make a digest. In other words, you hash this. You create a hash value for this, and you send that to the server, and then the server will check for the request that you're making for the user that is actually making the request, whether or not this hash checks out. Is this actually the right hash? Okay. So the assumption is that the server does have in its database the clear text user passwords for this user. But then you can easily check that. So here's the situation. We have a client here with the username and password, and a server that also knows the username and password. The client tries to get access to some document, say index.html, over HTTP 1.1. The server says, sorry, can't do it, 401, and unauthorized. What you need to do is provide authentication, and you're going to have to do that with nonce 1234, so some arbitrary number. Okay. Client then generates some hash over these fields that I mentioned earlier. So it provides a hash, and we all know what a hash function will do. It's really difficult to find another source or to determine the input that created the outcome of that hash. Okay, so it's easy to calculate the hash. It's really hard to do the inverse. Okay, so it creates this hash over things such as the username, the password, the nonce, the method that you're using, the document that you're after, and some other stuff. And that is going to be part of your response. Okay, so you're creating a new request on your second attempt, which still contains, the method and the document, etc., and this authorization header, right? With the username being Herbert, the nonce being 1234, and the response being this hash that we just created. Okay. Note, we do send the username, but we no longer send the password over this connection. We only send the password in the form of this hash. So it was used in generating the hash. Okay. So the attacker cannot change the request, cannot change the request to, for instance, obtain a different document, because this is also calculated in the hash. So you cannot change the username. You cannot obtain the password. You cannot change the request, and you cannot replay the request from a previous time because the nonce will be different. So all of these things now protect this request. Clearly, this looks much, much better. The question is this by itself good enough? And the answer that already suggests itself, I guess, is no, of course not. Okay, so one of the things that are still possible is the man in the middle attack. So we could still have the following situation. Given that a more advanced authentication scheme, what we could have is a client communicating with a server. Okay, and the client wants to communicate with whatever method the server provides. But if there is advanced authentication, we'll use advanced authentication. But if there is a man in the middle that intercepts the messages, and we've seen how to do this in previous videos. If you're intercepting the messages, you as an attacker could simply say, I am the server, right? And I want to talk to you, and then I'll relay the messages to the actual server. And what I'm going to tell you is that when you try to contact a server, let's say, mybank.com, you will actually talk to me. And I will tell you that we don't use advanced authentication at all. We use basic authentication. Okay? And that means that you will send me your username and password. And once I have that username and password and everything else, right? So the resources that you want to obtain, I will then talk to the actual server using advanced authentication, because I have all of the information that I require for that. Okay, so I will relay your messages, so the content will still arrive at the client, so you don't actually see that anything is out of the ordinary, but all of this information has now passed through our man in the middle. Okay. To improve authentication and registration of websites and so on, nowadays you can make use of the Web Authentication API, okay, an extension of what is known as a Credential Management API, and it enables strong authentication, so advanced methods that allow you to make sure that everything is encrypted, that you can use two-factor authentication, and all of these other things that you require for more secure authentication. So, but it relies on things that are somewhat outside the browser, so external to what we're currently considering. So we're not going to skip this for now. Instead, we're going to now move towards the topic of state. So HTTP by itself is a stateless protocol. And that means that the applications that require state need to, transmit state with the interactions across the internet. So the state itself must be transferred somehow between the client and the server in the form of cookies, or in the form of URLs, or in the form of forms. So let's have a quick look at how this is actually implemented in practice. So what you can do is, when you're a server and you so a client has come and visited you, you're going to provide a website to the client, and when the client clicks anything on the website, you want to remember who this client is, right? So what you can do to help you, because normally this is stateless, so you're forgetting everything. But what you can do is make a tailored website, right? So a custom website for this client, which contains user-specific information in every link. Okay, so for instance, your client asks for a page with the username and password, and what you're going to provide to the client is a page that contains your usual information with a catalog in this particular case, but also all the links will contain things like user equals foo. Okay, so you initially authenticated the client perhaps, but now you're in the follow-up exchanges, so the follow-up requests, you're embedding the fact that this is user foo in the communication. Okay? You can do the same thing by embedding this in forms. So if the user has to go through forms, you can also embed this information in the in hidden fields, okay, hidden input tags. Okay, so for instance, here we have a form and there's an input of type hidden, and it basically indicates that the user equals foo. So very similar to what we saw earlier. And finally, we can implement state using cookies, which contain a little bit of data that is stored at the browser side and will be automatically sent to the server whenever the browser contacts the server again. Okay, so the server can set cookies by including a header field, set cookie. For instance, in this particular case, we include a cookie that indicates that the user equals foo, and then some preferences for the user. And then every time the user contacts the server again, this cookie will be automatically sent as cookie user equals foo, shipping equals FedEx, right? So the preferences. Okay, so now we basically implement state in a sort of in a stateless manner, right? So the communication in itself is stateless. We're just transferring the required state every single time. So for instance, we can use these cookies to maintain state across different connections. And cookies may contain many things: the user preferences, some status of a multi-step process, right? So shopping carts, they will allow you to sorry, they will require you to add things to the shopping cart. So that means you're adding stuff to the cookies, and then at some point you need to take that and pay for it. Okay, you can also use it to store session tokens and so on. The cookies on the client side may be accessed by JavaScript. Okay, and there are some limitations. So you cannot just access any cookie on your client side, so from the browser. And there's so-called same origin policies that force you that restrict you to only those cookies that have been set by the site that your JavaScript is also from, right? So you can only access your own cookies. That is sort of the idea here. But we'll talk about that, the same origin policies and issues with the same origin policy in a later lecture. So cookies have a specific structure with a number of fields. So they have a name and value component. That's the only field that's really mandatory. And it can be anything, right? So it can be user equals foo, it can be favorite food equals pizza, anything that you want, right? Then you can optionally add an expiration date for a cookie so that it doesn't remain valid forever. A path can be set, which is the set of resources to which the cookie applies. A domain by default is the domain is the host name of the web server, but you can also specify something else there. You can have an indication that the cookie can only be sent over encrypted connections, right? So SSL connections, and you can set an indicator that the cookie should not be accessible to client-side scripts at all, right? So HTTP only. So secure and HTTP only are two important measures to increase the security of the cookies. And finally, there's a limit to the number of cookies that you can set as a server. Now, cookies and also some of the other things, so the custom URLs in forms and other web content can be used to implement sessions. And sessions represent some time-limited interaction of a user with a web server. Okay, HTTP by itself doesn't really have this notion of sessions, but you can use these cookies, these URL parameters, or these form fields, the hidden form fields, to implement the notion of sessions. Okay, so you create a unique ID at the beginning of the interaction with the web server, and then every time you communicate with the server, you include that session ID, and then the server knows which session this communication corresponds to. All right, so these are some basic components of the web, mostly the simplest kind of interaction that we have, a client talking to a server. We've started touching upon the notion of a client-side application, so client-side JavaScript, but not really in any level of depth yet. We haven't even talked about the server-side applications at all. So this is what we're going to do next.